Okay, let's give this set up here. Forgot to add the webcam, so let's just go ahead and do that. Anytime I change anything on OBS, Twitch, etc., and I have to set things back up, I always forget something. And this time it was the webcam. All right. Howdy, everybody. How's it going? I am today going to be working on a DDR2 controller in nMigen. nMigen. I think it's supposed to be nMigen, but I always say nMigen. The reason I'm doing this is a secret, but I need a DDR2 controller for a project, so I've been working on one. Things are in a little bit of a messy state right now. As you've probably noticed, I haven't really streamed in about a year, but I mean, can you blame me? It was 2020. So I'm going to be basically cleaning this up, getting it ready for kind of an independent release. The reason I'm writing my own instead of just using light DRAM is, for one, it's in original nMigen, but mostly I just find LightX to be kind of heavyweight. I don't really want to pull that dependency in. And also, it doesn't really mesh with the way that I kind of think about FPGA projects. It's very CPU centric, so figured I would just write one for my own sort of edification. Where I'm at right now is I've got the PHY kind of wired up, and then I have kind of half-sketched versions of all of the intermediate modules. I got really far into this project before I realized how weird the ECP5 PHY was going to be. So that's what we're going to work on today. Is I have this test that I run. And what that does is basically, instantiates the PHY module and then kind of walks it through the basic initialization sequence. And we should get, if I spawn myself a, let's guess that it's USB 2. Oh, I think I actually turned off programming. We should basically get the letter C screamed at us if we pick the right terminal. Nope. Where are we, friendo? Okay, that's sort of troubling. Hey, Dub. Thanks for stopping by. This is always the trouble with FPGAs. The biggest hurdle is that maybe it will just give you nothing, and then you have to kind of figure out why. Okay, so you can see over here that we're placing and routing all of our PHY nets and stuff. We end up with a few different clock domains. We can see it's identifying VREF correctly. So basically what we're doing is replicating an image from this document for our PHY. We're using essentially this setup, which is the ECP5 FPGAs have kind of a special thing which handles DQS, because it's not a free running clock, it's a data strobe, but it runs fast enough that we need to treat it kind of specially, and the interface is synchronous to it and all that. So it has these these custom modules, these specific purpose modules, and I've basically got this all wired up now in exactly this pattern. So we have a clock that comes into a PLL, the PLL produces the edge clock, we divide the edge clock down to run our logic. The edge clock is running at 200 megahertz right now, and we use basically 4x, it's DDR2, so it's 4 inputs per clock. And we've got this all kind of hooked up. And then the intent is that it's going to go through and initialize the RAM, and we'll be able to see that sort of transaction happen. But because I pulled all this stuff out, a bunch of it's probably broken. Let me just... oh, well, the UART's not plugged in, so that's probably why. Let me just fix that. Okay. All right, so that's USB 0. And what are we setting as the period of this UART? 115,200. Oh, there we go. Letter C over and over again. Okay, so that's what I expected, because these are basically open loop, these first three states. Okay, so we've got this phi set up, but what we don't have is there's this mem sync thing, which is intended basically to synchronize data coming in so that it doesn't put this whole interface into an invalid state. It's a soft IP block in Diamond, so it's not actually a physical thing that's in the chip. So we're just going to go ahead and pull that up, take a look at it, and see what of it is actually necessary for our purposes and what is not. User local? Yeah, Diamond. It has been a while since I've streamed anything technical, so trying to get back into the swing of things. Excuse me. Ah, okay, there we go. ISP FPGA, is that what we want? Not actually sure. I feel like I've definitely found this thing before. Let's check it out. SA5P0. Yeah, okay, so this is it. So this is just the thing that they have, and I think it basically is going to... Yeah, so this is how you interact with the PHY system from your sort of external clock. Because we have, in our example, we have a 60 megahertz clock coming in, and then we do PLL up to 200 megahertz, and then we divide down to 100 megahertz for this zone. But our application logic is still running on that 60 megahertz clock, so that's going to be our start clock in this case. Reset, DLL lock and PLL lock just come straight in from the PLL. Update is how you say, like, yes, I need to change this thing. And then pause, stop, freeze, ready, reset, blah, 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 blah. So what are we actually doing here? I guess we're just synchronizing stuff. Reset sequence 1 hot FSM. Wait for the DLL. Assert freeze. Stop. Reset. Pause. Control. Ready. Okay. I don't actually know how relevant any of this is. Oh, hi, Di. You're number 1. Founder, 15-month subscriber. That's way too long. Especially since I didn't stream for 11 of those months. Okay, I don't really think this is all that important. So what this basically does, as far as I can tell, is it's gonna just do reset sequencing. So we wait for the do we wait for the PLL lock? Because that seems like a good idea. Okay, no. So we wait for the DLL lock. And then once the DLL is locked, we wait a certain amount of time, which is this count lock parameter. And then... not sure what this freeze is about here. Yeah, I mean, I think this is basically just like we're going to hold the DLL frozen until it's locked. Or maybe if it doesn't lock in a certain amount of time, then we freeze it. Let me look up the documentation for this primitive. All right, so freeze releases the DDR DLL input clock. Should run at the same frequency. Reset input. Update control. Should not be active during a read or write cycle. DDR delay to be used in DQS buffer DLL del. Lock. Yeah, okay, so that's, as far as I can tell, it's basically just locking, waiting to see if it locks. Throwing shit at yourself. Was I? Oh, for not streaming, yeah. So we wait till it locks, and then if it doesn't lock in a certain amount of time, we freeze it to let it, like, try again, I guess. What is flag in this context? Signal to determine next FSM state. Okay, so nothing particularly interesting about that. All right. I don't think this is a big deal. If it turns out to be a problem, we can deal with it later, but I honestly don't think it's going to be that big of a deal. As long as we're not, like, updating the DLL or resetting anything or whatever. Okay, whatever. Let's just skip that then. So I made this DDR5 module. Let's open that up. We can stop looking at C going forever. Oh, also it's called Drama Mine because I wanted to call it Drama for DRAM and then A, just because it made a word, but that's already exists on PyPy. And then I wanted to call it Dramamine, but that's a trademark, so I guess I chickened out. So I'm calling it Drama Mine because I'm rewriting a perfectly good DDR core when one already exists. All right, so I really got to change some of these names. Okay, so this is my Phi module, right? So it basically, it's all the platform specific stuff. So the goal of this here is that we want to just deal with, oh, this is the tri-state, not W. We want to be able to just deal directly with the Q and R pins on a cycle-by-cycle basis, right? The read and write of the DQ pins, and not really have to worry about all of the messy stuff around the Phi. So I think that should basically work now. I've got everything all wired up. Let's see. I know what we'll do. We're gonna export the DLL lock, maybe. Well, no, because that probably isn't gonna lock. But we can export the PLL lock at least to make sure that the 200 megahertz clock is running, and maybe some other status signals. And then we can set bits based on them. I really need to, like, just open another copy of this and leave one open to the diagram at all times. Okay, I have gone to the wrong place. Where is it? Aha, there we go. Okay. I am going to just open another copy. Okay. So what data signals do we have here? We've got lock from the EHX PLL. We've got lock from the DLL. We've got DDR delay. That might be internal. I'm not sure we can actually pull that out. Okay, that seems pretty good. Oh, and then we have RDC flag, whatever these all are. Okay, so that's 4, 5, 6 bits. So we'll just start with A, and then we'll add whatever that comes out to in ASCII. Excuse me, go away. Okay, there we go. And then I'm just going to go ahead and close up some stuff here. Okay. All right, so that's what we're going to do. We're going to turf those signals out. So we've got them, right? We're just going to have to make a signal to carry it. Self dot PLL lock. Self dot DLL lock. Self dot RDC flag. WRC flag, data valid, burst dead. Oh, 6 viewers. Wow, welcome everyone. Thanks for joining me today. Feel free to say hi in the chat. We're just going to be working on this thing for a little while. Trying to just figure out what's going on inside this hard silicon, get it all squared away so that we can start working on more domain specific stuff rather than chip specific stuff. All right, so everything that comes out of that, there's 2 signals of, because it's 1 per DQS group. So basically, instead of making new signals for these, we will make them go outside. Okay, so we can get rid of these 2. And then the PLL is an instance. It's probably up here somewhere. Yep. Okay, so here's DLL lock. And then the PLL is up here. Self dot PLL locked. What am I missing? RDC flag and WRC flag, which is again on here. And I guess I just don't set those or use them or anything, which makes sense because I'm not actually sure what they do, and I should probably look that up. So if you're not familiar with nMigen, but you are familiar with other HDLs, this may look pretty weird. nMigen is an embedded DSL in Python, and these modules are instance modules, which basically means that they take Verilog or other like black box modules and say, okay, I need to talk to this. I promise I know what its ports look like, and then it lets you use it in your nMigen code. Okay. That seems like it should be good. Let's just run this again, see if it explodes on us. Nope, looks like it was routed. So that's all good, and now we will go over to our init test. And instead of these things, what we're going to do is m.d.sync plus equal counter equals ord A plus status. And status is going to be signal 6. And status is equal to... Actually, I probably don't need an intermediate signal for this, do I? Cat phi dot all of these. PLL lock, phi dot DLL lock, phi dot RDC flag, phi dot WRC flag, phi dot data valid, phi dot burst det. Okay, so this is the letter D. Excuse me, cat. Hi, Mom. That was my mother. Just subbed at tier 1 for 6 months. That's very generous. I didn't even know you could sub in advance on Twitch. Is that a relatively new thing? All right, so calculator, programmer. Okay, so we know that 65 is A, which means 66, 67, 68. So 68 minus 65 gives us 3. So we have 1, 1, which means that the PLLs are locked and the DLL is locked, but none of the rest of this, which kind of makes sense because I don't think we're actually transmitting anything. So that's a good sign. One weird thing about nMigen is that this is backwards from how it would be in Verilog because it follows the Python convention with the least significant bit on the left. There's really no winning there. That's the decision that was made. It's well documented, but it does trip up a lot of people who are new. All right. So assuming that this all works, now what we need to do is I have this DDR2 init module, and what that is intended to do is just bring the thing up. It has there's like an initialization sequence for DDR2 modules, and I wrote just a nice little state machine that kind of walks us through that. And this actually sends commands back and forth, or it doesn't send commands back and forth. What it does is it sets up commands into a FIFO, because if you remember our diagram from before, our E clock is 200 megahertz, but even this inner clock is 100 megahertz, which is a lot. That's like very fast for a chip of this speed. And so it's going to be... Actually, I might have that wrong. I think the E clock is 400 and the internal is 200. So that's a lot for a chip this fast. So we want to keep as much logic out of that as possible. So what we have is we have a FIFO. It's going to be an asynchronous FIFO that ferries commands back and forth between kind of the front end of the module and the back end. And we want to minimize the amount of logic that needs to live in that back end because it's got to be very fast. So we separate that out. We've got this init module that walks through the states and puts them into this FIFO. And then we're going to have our... I didn't really have a good name for this, so I just called it like a chip module, which does the actual reads and writes to the pins. And this one is a bit screwy because, like I said before, I didn't realize how the phi was going to have to work when I started this. I assumed I would have a generic 4-to-1 DDR or 2-to-1 DDR, however you want to think about it, 4 bits per cycle. But I don't. I have this funky thing, so I had to write this whole phi module. So what I need to do now is just kind of tweak. Well, first I need to set up this module, the init test module, to actually include the chip, which I had at one point right here. And we're going to need to glue together that module with the init module so they can kind of drive each other. But in the meantime, I need to get my I need to get it so that this module will build, frankly. That's the first step. So we're going to go through that and find all these places where it doesn't quite work. And we're just going to go ahead and patch those up. So 255 is right here. Okay, so for all of those, we are fine. I think DQ is going to be a little bit different. So I was originally just passing in the pins directly. I had a DDR2 pins, which is just a named tuple. And I was passing the pins in directly. And I think I still pass the pins to the phi directly. No, I don't. Okay, so I don't pass the pins object. So I'll just make in the pins object that the DQ is a 4x4 or 4x16 list. And then we should be good. Okay, so we've got pins. Where are we? DDR2 pins, which is right here. And then what we want is pins handle is going to be DDR2 pins with, grab that so I know what I'm looking for. CS equals DDR2 pins.cs ras You know what, I'm gonna put the .o in here too, because there's not really any reason to pass the whole pins object. Welcome viewers. If you want to chime in the chat, I'll be sure to address any questions or anything like that. In the meantime, I'm just gonna keep talking to myself, which nobody wants that, so by all means, chime in, engage, or don't, whatever makes you comfortable. What we're working on here is a DDR2 controller in the nMigen HDL, which is an embedded Python DSL. Oh yeah, okay, so those are the wrong ones. DQS equals comma, DM equals comma. And then, okay. So all of these need to come out of the phi, which should probably go up here. All right, so then DQ is going to be the phi's. Whoops, hang on. What did I call it? Phi dot, I think it's QRWT. Okay, yeah, so we got to actually change a little bit more than this, because we need to make it so that we have DQR, DQW, and DQT. And then the DQS and DM will be fine. Or maybe I should make those records that just kind of look like real pins. Whatever. No, we'll stick with this. This is fine. Okay, so this is going to be DQR is equal to phi.QR, WW, T, QS. Wait, why is there a QST? That doesn't really make sense, does it? Here are these tri-states. Is there a tri-state for, I guess there is, DQ and then DQS. Yeah, okay, I guess that makes sense actually. So, okay. So QSR, QSW, and QST. Except I don't think we actually need the RW, do we? What comes in from the rest of the world exactly? No, because the actual DQS pin is controlled directly. So all we actually need is the QS direction. that explains why that was the way that it was. And then DM, I think I just didn't do in here, which is not ideal. And that is, I think, also a 4. Okay, does that build? Well, no, because I still have this pasted in here. Right. I should, yeah, DQST. So I need to change this to take DQST. Right, and now if we go through all of these, starting at line 256, W0, right? So, oh, and then we do this over here, so that's good. W0. I mean, I can probably just DQW, right? And then DQR. Then this is a bit iffy because the DQS direction control is only 2 inputs, not 4, because it's a 2x1. What's the role of the strobe? Is it used instead of a clock on the bus? Yeah, so the strobe is edge aligned with, or is aligned in a defined way with the data and the the data pins. So when you drive out, you drive it with some defined alignment, and when you read back in, it comes in with some defined alignment, and the clock is free running. I'm not 100% sure why they do that. I think it has to do with the fact that you only want one like clock master. So the strobe is used to make the pins bidirectional, as opposed to doing something like embedding a clock in the data stream, which is what you would do in a high-speed serial interface. But yeah, you see those kinds of like data strobes often on wide bidirectional interfaces in particular. Okay. Yeah, so this is a bit iffy. So we're just going to drop this down to 2, which is not going to work, but that's fine. We'll fix it. Does not have a field DQW. What you talking about, Willis? It's right here. Oh, it's because I'm still passing pins and not pins handle to the chip. Okay. See, if Python had type checking, it would have caught that. Okay, and now it's gonna get mad. It's getting mad at me because I am still accessing the .O's here when I got rid of them because there's no reason to pass the whole pin. And then it's gonna yell because there's no more DQ anymore. This is in the wrong, like, arrangement, huh? If I print self.pins.dqw, I get caught up on this all the time in nMigen because I'm never sure whether the first index is against the width of the bits or like the list that they're in, or like the list that the signals are in, or the bits of the signal, or like, yeah, you get it. So I'm probably just looking at this wrong. Okay, so that's a list of 16 signals, which means I think all I need to do is get rid of this index. And that can go away. Expected duration got duration. That's fun. Oh, because I'm importing it from totally the wrong spot. What device is this? This is an init test, so we're just gonna go ahead and who is causing this trouble? Chip trials. I thought I fixed that though. All right, drama mine. Maybe I just don't understand Python imports. Actually, I know I don't understand Python imports. Why are you looking at the wrong file? Do I not have timer? Oh, I don't. Oh, no, I do. It's right there. So what's happening here is that this is grabbing the timer module from my my secret project instead of grabbing the local one, and I don't understand why that is, because it's coming from this file in elaborate, which is so this file and then that file. But they're all should be importing from right here, and I don't really understand what's going on. Why are you doing this to me? I blame Python. This feels like a Python problem. Did that fix it? Nope. How could this be happening? Okay, so there's a timer right here, which is only used, only used to slow down the output because I don't want to just be pumping out the signal at maximum speed. I've got this latching timer, and if we look at the timer code, so this is just some utility timer code that I wrote, which does a type check to make sure that you actually got, you know, some kind of timer. Actually, wait. Yeah, so it's getting mad about duration, actually, because I want to check and make sure that what you pass into a timer is actually a duration, and it's getting mad about that in the latch timer case, which is right here. So where are we getting duration from? It says drama mine timer. I really am not the biggest fan in the world of Python, and I do not understand why this is happening, but I'm almost sure it is a Python problem. If any of you are better at Python than me, please chime in. It apparently is not resolved by just rebuilding everything. which I didn't really expect that it would be. But, you know, you always kind of hope. Gateware course timer. Why are you gateware? Oh, it's probably because of this. Right? And then none of that should matter because I'm not instantiating any of it. And then in DDR2 chip by itself, we'll just go ahead and change that also. This is what happens when you migrate projects. All right, you happy now? Yay, you're failing differently. That's all I can ask for in life. Okay. So we can get rid of this print statement because it's not necessary anymore. Okay, list object has no attribute OO. Okay, I think all we need for length is this. Index 4 is out of bounds. DMO3I. Oh, okay, yeah. So I reversed all of this stuff so that it wouldn't be wrong, and then I went and flipped everything around. Okay, DQ is not defined. I can get rid of a print statement here also. I was having problems before, I guess. 83. I'm really off center in this frame, huh? The danger of global imports. Well, yeah. I mean, I don't even think I was. I think it's a relative import. I don't know why it works. I don't understand Python. I'm very bad at Python, especially the package management just doesn't make sense. I've tried to explain it to myself a dozen times and never really gotten it through my thick skull. Okay, so we want to be getting data, so it's got to be DQI. And again, same here, DQR rather. Oh, it's... What did I name it? It's in here somewhere. Alright, so DQI. I don't know why I switched between I and R, but it is what it is. Okay. Hey, that looks like it might be getting built. Cool. Okay, so that builds at least. Now I think what we are gonna want to do is hook it up to the init module. I don't 100% remember how that's supposed to work, so let's look at this. In here, self.command. All that stuff that they tell you in school about making sure you write actual documentation because the next person to read it will be you in 6 months, it's all true. That will not help anyone who might be listening, who's like in school or whatever, because you have to screw it up yourself 100 times before you realize, and even then, often you don't realize. But it is true, nonetheless. Okay, so we got command valid, and command ready, right? And then we need to glue those to the stuff that comes off of init, which is again command valid ready. So we got to just glue those together. So we're going to go ahead and do m.d.com. So this is how nMigen does always add star. Is you add stuff to the combinational domain, And then we're going to do phi.command.equals init.command. Or no, not phi, sorry, chip. Chip.command valid. Or no, command. Yeah, okay, so command valid equals init.command ready. And then init.command valid.equal chip.command ready. Oh, and then I need to delete these notes. Okay. Is that gonna work? Command valid is driven from multiple fragments. Top and top.init hierarchy will be flattened. I think I got those backwards. Okay, command valid is an output, command ready is an input. So the command ready. Oh, I just straight mistyped it. My head was out to lunch. Okay, go. I wonder what switch boy is. Okay, so we programmed something. It's still spitting out D's. I guess that's not too surprising, but let's look at the state of the init module. Where's the init modules? State, because I had some stuff before about that. Ah, okay, so we have an initialized flag. Okay. So if init.initialize, then we're gonna do Z. Or no, you know what? We're gonna just turn lowercase. And that way we can still see the statuses. So if we're lucky, we'll get a lowercase d. Yeah, I didn't think that was going to happen. Welcome to everyone, by the way. I noticed the number has climbed as high as 7, so thank you for joining me. I appreciate it. We're working on a DDR2 controller. Speak up in the chat if you have any questions or just want to say hi. In the meantime, I'm just going to keep narrating my every action out loud, under the theory that that's what makes good content. I think the fromx import y line caused issues because you imported 2 timer modules into the same scope effectively, but nMigen recommends that import style from convenience, I suppose. Yeah, I think, I don't know, because I was importing from Gateware, which isn't even in this repo, so I must have installed something that gave me access to that module. Like, I would have expected that to just fail by not being able to find gateware.cores, but I guess I pip installed it at some point. I don't know. Okay, so where was I? Right, I was going to check if init has any other useful outputs for me. Oh, I know. Okay, here's what we're going to do. Let's say this is a 4-bit signal. And we're going to do with m.if init.command ready and init.command valid m.d.sync plus equal status plus status equals status plus 1. Okay, and then we'll see how many commands we send out. And the expectation here is going to be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or so. But the actual answer is 0. That's interesting. Okay, so command valid is right here. If we ever make it past CKE, we should get that. Whereas over here, command ready. Wait, I had this backwards, didn't I? Yeah, okay. So what I want is actually, I want chip.command valid. It's probably still not going to work, but that's okay. Okay, so we're still saying A. Command ready. Okay, so I'm combinationally assigning command ready to 0. And then setting it based on switch boy. And I was getting an error about switch boy. Is used but has no driver. It should. Isn't that what this should be? Okay, so in this case, I have command valid as an output. And in this case, I have command valid as an input. Okay, so I think I just need to reverse those, although that's not very sensible, is it? I really need to clean that up because it's a very confusing thing for something that really shouldn't be that confusing. They're gonna yell at me about multiple drivers again. Doesn't look like it. And you're not complaining that Switch Boy has no driver anymore. And hey! Okay, so we made it through our thingamajig. But it looks like we lost our PLL lock? That's not good. Oh wait, no, okay, because I changed what status means. Alright, so that's good? Question mark. I feel like I should have sent more than 2. I bet I'm crossing clock domains because I didn't pay enough attention to what domain things are in. Okay, so let's go through that then. Starting at the top, we've got phi, which, if I recall correctly, yes, hello cat. I domain is sync, O domain is DDR2, E domain is E clock. Right, so we've got sync domain, E clock domain, and then the O domain is this clock div X, right? And then we put the init module in that domain because we wanted it to work. It's really too big to be in that domain, and we should really cross it with a FIFO, but for now it should work fine. And then what we didn't do was put the chip module in that domain. So it's probably doing all sorts of bizarre nonsense. Okay. bit odd. I still expected a little more. You just run it with status over here real quick. Assertion error, assert sig is self. Well, that's always fun. You know what, maybe I should just make everything sync. Alright, so let's do this instead. And then when we do the phi, which is right here, we're going to do I domain equals source, O domain equals sync, and then we're going to remove these domain renamers. Wow, 10 whole viewers. Thanks everyone for stopping by. I really appreciate that. We're working on a DDR2 controller for the ECP5 FPGAs in the nMigen programming language. DDR2 is used but not defined. Where though? Is there something in here that uses DDR2 directly instead of using O domain? Why nMigen? I help maintain nMigen somewhat. Okay, right here. Also, it's convenient to have a lot of the environment kind of integrated in a way that you don't get with something like Verilog or VHDL, right? Like there's no package manager for Verilog. Well, there's FuSock, but you know. So I don't know. Honestly, the reason I got interested in it in the first place is because of a series of coincidences involving being a fan of White Quark's work and some collaborators on a project wanting to use nMigen for it, and basically saying we can't work together if we don't do it in nMigen. And I was like, all right, fine, I'll learn something about what this is about. And it's nice. I like a lot of things about it. I like that it has a lot less weird edge conditions than like Verilog does. The integrated simulator is a godsend. There's some things I don't love about it also, but by and large, I would say I'm a fan. Okay, so what now? Oh, because the UART is now in the sync clock domain, so now it's running at the wrong speed, which is what, 200, I think, which is a lot, but Python is indeed much friendlier than Verilog. See, I actually hate Python, but I mean, it's probably still friendlier than Verilog, to be fair. Friendly and Verilog don't really go together. But yeah, honestly, all of my biggest problems with nMigen are actually problems with Python. I really screwed things up by just cavalierly messing with clock domains, huh? Oh, I should probably be on the actual right baud frequency. Okay, I think probably the right thing to do here is actually to cross the commands properly and not just try to wing it. I do think that the chip needs to live in the DDR2 domain, so that's not wrong. Why didn't we like this? Okay, so we're getting lowercase c. Which means that we did reach the initialize point, but we also only wrote 2 commands, which doesn't really make a lot of sense to me. How did that happen? Command ready, command valid. Is it because of how the switch works? What's going on here? If we get command valid, then we set command ready. Maybe I should only count readies from the command zone here. Thanks for stopping by the way, Horses Fly into Buildings. That's really nice of you to take time out of your day. Oh, hey, we're failing our clock domains now. That's good? Question mark? Alright, we should run this with nMigen verbose so we can see what's actually happening in XPNR. Alright, so 184. Yeah, it's in init, and it's in command, and it's in the combinational feedback on command ready. So that, yeah, I mean, sure. That's exactly why this shouldn't actually be built this way. Okay, so let's try and really cross the streams a little bit better here. Do I have an async FIFO stream? I feel like I did write one at one point. No problem. Always like low-level development over the typical game dev, web dev stuff on Twitch. Yeah, I mean, I like watching game dev, and I have huge respect for web devs. I don't know how they keep up with that industry. Every time I have to open it up for some reason, I am more humbled every single time. But that being said, it is nice to see some other stuff every once in a while. Do you watch a lot of Twitch, or are you stream yourself? Okay, so let's drop DDR2 from init here. Obviously this isn't gonna work because they're in the wrong domains, but we can run it anyway. Okay, now it says L. No, just randomly saw your stream. That's awesome. I'm glad to hear that we're getting some, what do they call it, organic traffic. I feel like a lot of the people who follow me do it because they know me from a Discord server or from Twitter or something like that. So it's really cool that you just kind of found it on Twitch. Okay. So this is another project, which is where I got my stream abstractions. Sync FIFO stream, async FIFO stream. Okay, yes, this is what we want. Oh, how cute. Look at me trying to actually use type annotations like they mean something. Payload type is... Boy, I don't remember how how to do layouts at all. From nMigen.lib. Nope. Yeah, I didn't think so. nMigen HDL rack will give me layout. Yeah, there we go. Okay. Well, that's not very helpful. Fine. Let's look up the record tests. Test HDL rack. Right, okay. List of pairs. Which is gonna be init.command. Can't you do like a layout from shape also? Shape.cast, something like that. Whatever, I can't remember. This should work. init.command.shape. Okay. So that's payload type equals depth equals 2, SOP equals false, EOP equals false. And then shouldn't it have something to specify the domains? Yeah, this doesn't seem right. This is fairly iffy. All right, I'm just going to lift this whole thing up and redefine it because it's clearly not correct. As anyone who knows me will know, me from 2 weeks ago was an idiot. No, that's not true. But this is kind of an issue. So, okay. Let's just directly define width as an int and depth as an int. Let's get rid of the SOP stuff. Let's call it async FIFO stream 2 just so I don't get screwed up. Stream source is kind of a stupid thing anyway. I just won't use any of that. Just rip this up. Okay. Signal of width. Signal of width. FIFO is async FIFO. Okay, right. And then we need R domain stir, W domain stir. Okay. Just take a quick look here and remind myself what this interface looks like. Okay, this is all dumb. Go away. R domain equals R domain. W domain equals W domain. Okay. Yes. Okay. Streams are an abstraction that we really want to add to nMigen, but we have so many other like higher priority things to work on that we haven't really had time to dig in. It's a surprisingly nuanced like abstraction to try to get 100% right. Sync is the input. And then source is the output. And again, input. Sync is the input. Output. Okay. So that ought to work, and then keeping that up here. Thanks so much, everyone, for stopping by. I really appreciate you taking the time to see what's going on. We're working on a DDR2 controller here in nMigen, which is a Python DSL HDL. And I'm currently trying to get clock domain crossing correct, which is always super fun. But fortunately, nMigen makes it relatively easy as long as I get my head screwed on straight here. Okay, so width equals init.command.shape.width. Depth equals whatever, let's say 4. R domain is DDR2, and W domain is sync. Does that work? Let's see. Hey bro, is this DDR2 as in RAM? Good to see you. Yeah, hey, how's it going? Yes, it is DDR2 as in RAM. So on my secret project, it needs a little bit of big cheap storage, and the best way to go for that turned out to be DDR2 specifically, because it's old enough that it's cheap but not so old that you can't buy it. It turns out it's kind of uncommon though in the open source FPGA world. Most people either jump all the way to DDR3 or just use SDRAM, which is like the really old stuff that's super simple to talk to. The reason I didn't want to do that is basically cost, and also I just kind of like DDR2. I think it's in a really sweet spot in terms of DDR3 is really complicated to try and talk to. It has a lot of like initialization and training and stuff. And DDR2, I feel like, is just at the edge of what is sensible to do in pure HDL without embedding a whole CPU, which is what light DRAM does. And that's why I didn't want to use them, because I feel like it's not necessary, and it's just not really how I think about FPGA projects, is like a very CPU-centered approach. Although a lot of people do approach it that way, and that's totally fine too, of course. Okay. So now we're getting the letter G, which is a good sign, I would say, arguably. What am I getting that on? Chip.command ready. Okay, so... Oh, I have this wrong still, because I didn't actually hook up the stream to anything. So let's do that. All right, so chip command becomes FIFO.output. Chip command valid, which, if I remember correctly, I had that as an input. Yep. So that's an input, which means it needs to be an output from the stream. So it's got to be FIFO.output valid. Yeah. And then init command ready is going to be FIFO.input ready. Yep. And all right, so we need FIFO dot output ready is gonna equal chip command ready, and FIFO input valid is going to be init.command valid. Yes. Huge shout outs, by the way, to Dave Shaw and everyone who's worked on NextPNR. It is amazing that I can just hit route and it'll just work. And it won't take, 20 minutes to route. We can just test things immediately. It's great. Howdy, MetaConstruct. Thanks for stopping by. How's it going? Having a good evening? So did you buy like a completely blank DDR2 stick? Not quite. So I designed a custom PCB that has on it the same chips that go on sticks of DDR2. Does that make sense? So the DDR2 has like 8 or 9, depending on the configuration, or 16, or you get it. It has a large number of these chips on a big module. Oops, sorry, I hit the mic. I'm still getting used to having a discrete mic. And I just got one of those chips and routed it directly to my FPGA. Okay, so what happened? We failed our routing timing. And why did we do that? So we've got our chip in DDR2. Oh, because I'm not using async FIFO buffered, I bet. Let's try that. What do you mean it's not defined? From nMigen.lib.FIFO import async FIFO buffered. Late coffee time. Oh god, I want coffee so bad. I would love some coffee right now. Still failing. And why exactly? Coffee rules. Coffee's so good. I've been trying to cut back just a tiny little bit because I've been drinking too much coffee. I maybe should drop the speed a little bit. But that's kind of complicated because I have to rerun the PLL generator. What if there's a flag? A specific brand of coffee? I mostly just drink Folgers, but my friend Chris got me some really nice coffee from like a local place in Irvine recently. I can't remember what that place was called. It's called Gaelic Grounds. That's right. That was really good stuff. There's also Stumptown in Portland. When I used to go to Portland a lot, I would drink Stumptown coffee a lot, but not so much anymore. Boy, we're really failing that by a lot. The right thing to do is probably to pipeline it, but I don't really want to screw with that until I know if I have things in the right spot. Is there a NextPNR command? Oh, yeah, NextPNR ECP5. That will let me just ignore timing failures. Timing allow fail. Oh, that's not where that is. nMigen boards. Okay, let's see here. Oh, there's probably no good way to do that, is there? Man, Stumptown's a classic. Stumptown is a classic. Although what I really miss about going to Oregon regularly is more ready access to Deschutes beer. I swear those people never make anything wrong, beer-wise. Boy, I don't want to be screwing with this at all. Available overrides. That's for Diamond. Trellis. Next PNR options. Okay, that's probably what we want. Not actually sure how that's supposed to work. How does get override work? Templated platform. All right, let's look at that. Build plat templated platform. Get override var env. Okay, so we can just do this. Next PNR ops equals timing allow fail. Does that work? Word. Yeah. I mean, Deschutes is great. They're so very good. Oh, is Nightbot dead? I've been live for an hour and 25 minutes. Okay, so we get H, which, boy, I'm really messing this up, aren't I? The heck is H in ASCII? I have no idea. Alright, well, we can solve that with the magic of the internet. ASCII table. Alright, lowercase h is 104, 97. 104 minus 97. 7. Okay, so we sent either 7 or 8. No, 7. We sent 7 commands. Does that match up our expectation here? Best website. What, ASCIItable.com? Okay, where am I? Here, okay. Oh, I was gonna look at init. Okay, so what commands did we send? We send precharge, MRS2, MRS3, MRS1, DLL reset, precharge 2, auto refresh. Auto refresh 2, delay, MR set, MR set. So that should be like 11. So that doesn't seem right. Always got it open in a background tab. By the way, everyone, how's the audio quality when I'm not smacking my hand into this microphone that I'm still not used to having? This is still a pretty new setup. I'm still kind of experimenting with things. In particular, if the keyboard is super loud and annoying and distracting, then I need to get like a shock mount for the microphone. I probably should do that anyway, but just in general. Sounds good to me. All right, good. Glad to hear it. You know what? Here's what I'm gonna do. I'm gonna slow this down. FIFO input valid only if timer.output. And then things will run a little more slowly and we can maybe watch them a bit. Huh. That's weird. That's sort of strange. Oh, no, maybe it isn't strange because it's going to be... Yeah, okay, I just did that completely wrong. That's why. Sounds all right here. Okay, good to know. Thank you. Okay, see, this makes a little bit more sense. We're getting some capital G's. Does it make sense, though? Probably not. I mean, we're failing timing by like 60 megahertz. I probably shouldn't even be trying until I get that fixed. Annoying. Okay. Let's look at our critical path here. Okay. Source is from the FIFO's R data to the TRAS reset. Okay, because the FIFO R data is the budget, or is the command. And then it runs through all of this to the TRAS reset. Unbuffered.rn. Why does that happen there? I mean, I guess it's the ready feedback, right? Which is eating like 2.9 nanoseconds. Which is probably most of the problem here. Why are you going into unbuffered read enable? Is that how that works? I guess it is, huh? Alright, you know what? I'm just going to register it once. And it'll slow things down by 1 clock cycle, and later we'll try to fix it, but that's okay. Chip ready reg signal m.d.sync plus equal chip ready reg equal chip dot command ready. Output ready equals chip ready reg. Did that help at all? No. I think what I actually need here is I need a slip buffer and a registered output on command ready. Or a skid buffer, rather. but let's just, oh, this isn't the right file. Let's make everything slow. I'm sure it won't cause any problems at all. This is the kind of thing that I need to, this is why I need to stream more, because I am not used to having people watch me right now, and that's why I'm like, oh god, try stuff to make it work, instead of like going through methodically and like adding in a skid buffer. Although, let's be real, if I wasn't streaming, instead of going through methodically and adding in a skid buffer, I would just be like, well, I'll get to it tomorrow, and then stop. So, you know, trade-offs. How's that? Better? Nope. Well, I mean better, or differently bad, I guess. Why are we failing now? Command ready next from RAS. I'm actually kind of confused. Oh, it's up here. Nope. It's up here. Okay, what are we failing on now? From latch timer CCD to bank address? Jeez. Differently bad. I mean, that's all you can hope for some days, you know? I swear I had this better at one point. Gotta sleep for EM exam later. Stream was fun though. Alright, thanks Dub. Good night. It's like crazy o'clock there, so you should go definitely sleep. Okay. I really should be running this at a slower speed just to get it working, and then we can super duper fine tune everything. Okay, so let's go in and change the DLL speed. Excuse me? Where are you? Oh, it's PLL. ECP PLL, that's what it's called. Okay, we're just gonna go to 200 instead of 400. Okay, now let me just make sure that I didn't hard code 400 in here somewhere. Nope. How about in here? I should just get rid of this tab, it's not useful. Okay. Alright, let's drop the timing allow fail and just try to run it at half rate. Oh, and I should make sure real quick that that's actually a legal speed for the DRAM. AC and DC operating conditions. there is a thing in here about clock speed. I think it's like TCK. Is that what we're looking for? I mean, it's probably fine. Thank you everyone for stopping by. I really appreciate you taking time out of your day or evening, depending on where you are, to come and hang out with me, watch me bash my head against the wall for a little while. I mean, this is what it's like, honestly, most of the time when you are working on stuff. So, okay, 2.5 nanoseconds. I could probably do that in my head, but I'm not going to try because I'm on stream and people are watching. Wait, where is the... What's going on here? Where's the plus minus button? Oh, there it is, okay. 1 over 2.5 e negative 9 equals 400. Oh, I did it wrong. I had it backwards. I want 8. There we go. Okay, 125. So that's actually fine. Okay, cool. One day I'll find an excuse to play with nMigen. I don't understand anything that's going on, but it's fun to watch you work. Yeah, I mean, that's how I feel when I watch you stream. Everyone, if you're into EDM and dance music and things like that, you should go check out DJ Frank Willard's stream. Unlike me, he has an actual stream schedule, which you can find on his page, and he does like cool DJ sessions that I understand about as much as he understands HDL. He's my cousin. I can rib him about that if I want to. But yeah, you should go check him out. It's really cool stuff. I don't even really like that kind of music, but it still is surprisingly enjoyable even for me. So one day I'll find an excuse to play with nMigen. Yeah, so this is nMigen. I don't know how much of that history you've followed, but basically it's like a successor. nMigen had some design issues that were really difficult to solve in kind of a post hoc way. And so White Quark started up nMigen, which is just new nMigen, and it I have contributed some to it, and it's a pretty friendly community. I like it okay. I wish it wasn't built around Python, just because I don't like Python very much. But it's a pretty good like ecosystem, I guess is the best word. I don't love how there's like no package manager for Verilog that you can rely on, whereas with nMigen you kind of get that stuff for free, which is nice. Okay, I'm gonna clear this because I've lost complete track of what's going on over here. Barely aware of the distinction, but yeah, it seems neat. Yeah, it's pretty neat. Like, for example, if we take a quick look. So I just whipped up this async FIFO thing, and I was able to do that because I can just import the async FIFO from nMigen, and I don't have to, like, try to write my own clock domain crossing FIFO. So you're coding in HTML right now. No, so this is Python with a language embedded inside the Python, which is called nMigen. Hello, cat. How you doing? My cat is curled up in the cat zone, which is a heating pad that I have in front of my keyboard to try to keep him from sitting on the keyboard. It only sort of works because he still wants to snuggle, so he'll just casually sneak closer and closer until my keyboard's falling off the edge of my desk. What was I saying? Right. Okay. Okay, let's try and slow this down again now that we're not failing timing. I think I got as far as programming a hello world output text in Python before I quit. Yeah, I mean, it's not, what am I saying? It's not for everybody. I think there's been like an over emphasis on like everybody must be coder all the time, and it's kind of annoying, to be honest. But I do enjoy it. I just happen to get really lucky that this thing that I can't not do also happens to be something where they pay me. Because me no big brain like you. Nah, man, you just didn't spend like thousands of hours throughout your high school and college years doing this kind of stuff. Why are you mad at me? I don't like that. You are upset now. This is a real weak spot in nMigen, is that if you drive an input, if you drive an output with an, you have a driver-driver conflict on an instance, you just get this garbage error message about assert defs is self failed, and it's really hard to debug. Oh yeah, Diana, my only subscriber, or actually no, mom subscribed. Now I have 2 subscribers, both of whom know me. She has my subscriber emote, which is my cat Faint, who is adorable and fluffy and sleeping curled up in the cat stroller that my mom bought me for Christmas, just off frame. What am I doing? Oh yeah, okay. Why don't you like this? I'm confused. Oh, because I'm doing this also, which is of course not going to work. Okay. Is annoying sidekick Diana or mom? Annoying sidekick is Diana. Mom is AM Weigel. D. Last night Diana was on a different account. Yeah, so the streaming account is shared between Diana and her brother. So my last stream was playing World of Warcraft with Diana, and that was on her Zenethra account, which is really Russell's account, but he isn't around, so plot thickens. Oh boy, okay. I'm honestly not sure. I mean, this might just be fine. This is kind of the problem. I don't have really good introspection into the design, but I think this is actually fine. I'm going to call this good. Hey, would you look at that? I don't have sub alerts on this layout. I probably should, huh? Where's the redeem channel points to make you chug a beer option? Yeah, I don't really know what channel points is all about. Like, do I have to unlock that? How does that work? Oh boy, I'm starting to fade here, folks. Probably gonna be wrapping this up pretty soon. Oh, you just unlocked the emote via channel points for 24 hours. Okay. Yeah, I still don't know what channel points are, but I'll figure it out. Just because you keep bringing them up, I'll have to figure it out. I'm just scrolling up and down the page. That's not how you make progress. Okay, so let's pretend that this is all good. Because, sure, probably is. As far as you know. As far as I know. So what would the next thing be? Oops. Don't worry, Diana. It's not illegal on Twitch. Oh, did you look it up after we talked about that yesterday? Okay. So the next thing would be if we've gone through the initialization sequence. He'll keep bringing it up and you'll keep saying you'll figure it out. I mean, why you gotta call me out like that? The next thing I guess would be to hook up the actual memory controller element, which is almost certainly in a horribly broken state. So I wrote all this junk. Let's see if I can instantiate it. And then whether that works or not, that'll be the last thing for the stream today. Okay, bro, good night. I'm going to go work on a few music-related things. Catch you soon. I've been reaching it for my own channel, and people do what I think. Thanks, man. I appreciate you stopping by. I know this isn't really your thing, but I appreciate the solidarity and the support. Everyone, again, if you like EDM, you want to go check out DJ Frank Willard's channel. He has an actual stream schedule and stuff, so you can see when you're going to want to be checking that out. Really just chill EDM music, DJ streams. It's pretty cool. Oof, okay. Submodules. Control. Alright. Object none cannot be elaborated. Elaborate return none, missing return statement. Yes, correct. Wait, what? What do you mean it returned none? No, it didn't. Unless I screwed up the indentation here, which I guess is possible. Doesn't seem likely. Elaborate return none, huh? Interesting. Oh, no, I'm just an idiot. Okay, and then DDR2 timing is wrong because there's required stuff. Do I have a timing instantiated here somewhere? Yeah. Will you accept timing as an input? Apparently not. You really ought to. Pre-charge bank is referenced but not defined. Given the number of things that say to do, I don't know, some stuff. I'm pretty sure this is not useful. All right, I gotta figure out what's going on with this another time, I think. Good night, chat. Good night, A-Waggle. Thank you. Yeah, thanks, man. I appreciate it. Okay, so it built successfully. That's nice. Yeah, I'm just not really processing this right now. I'm pretty sure everything is cool. And I think I just need to hook up the command thing again by muxing it against init being finished. Okay. Initialized. Then we're gonna do all of this junk. Or no, so if else, right? And we will go in here and hook it up to control. Oh, no, that's right. Okay, is that good? We gonna fail routing again? No, okay, we good. All right, dope. Okay, so I got this all wired up now. That's great news. I'm going to call it here, I think. Coming up on 2 hours. That's not too bad for a first stream back onto tech stuff. And next time, which I don't know when that will be, I'm going to try to do something on a little bit more regular schedule, but life is so crazy just kind of across the board right now that who really knows. But I'm going to try to be back next week, maybe the week after. And I'm going to probably stream some video game stuff too on occasion because that's also fun to do. But yeah, I'll be back pretty soon. Thank you all for stopping by. I really appreciate it. If you want to follow or subscribe or whatever, that would make me very happy. But if you don't, of course, that's totally fine also. And yeah, thanks for coming in. It really means a lot to me. I had a really good time talking with folks, meeting some new people. Oh, before I go, let me demonstrate cat. Can y'all see that? Look at this boy. Oh, he's so cute. He's a good kitty. The other one is too far away for the webcam. I'll have a cat cam later. See ya. Peace. Yeah, thanks, Metaconstruct. All right. Good night, everyone.